Okay, this video is going to cover a few homework questions from Chapter 5. These first two are from Section 5.1. I'm going to work out number 10 and number 12. So for number 10, in the instructions that have been whited out, it stated that PQRS was a parallelogram. So all of the properties of a parallelogram are going to apply here. So remember, we have two sides. Opposite sides are parallel and congruent. So this side would be parallel and congruent to this side. So I can see, to find the measure of angle A, or side A, it's just going to be 6 plus 4, and A equals 10. Now also realize that we have parallel lines here. And a transversal. So because it's a parallelogram, PS is parallel to QR, and this would be my transversal. So I know I have same side interior angles here. So X would be 90 degrees because they're supplements. So 180 minus 90, leaving me the measure of angle X here to be 90. Now, if you notice right here then, we've got a little right triangle down here. So if X equals 90, then I know that the two acute angles of this right triangle are complements. So if I do 90 minus 45 to get the measure of Y, Y equals 45. Now if you notice, because I have two base angles here that are congruent, this is also an isosceles right triangle, making this leg and this leg the same. So this side of my parallelogram is 4, making side B over here of the parallelogram also 4. So A was 10, B was 4, X was 90, and Y was 45. And these were both degrees. All right, so let's go ahead and take a look at number 12. Now, a visual wasn't given, so let me go ahead and draw a picture, and I'm going to label it as STOP. And it told me that the total perimeter of this parallelogram is 54. It wants me to find the length of this side here, ST, and SP. So what it told me in the problem, it said that ST is 1 centimeter longer than SP. So what I'm going to do is I'm going to let SP equal X, and then ST, which is 1 centimeter longer, will be X plus 1. Remember, opposite sides in a parallelogram are congruent, so I'm going to put an X there and an X plus 1 there. Remember, perimeter means add up all the sides, so I'm going to add X plus X plus 1 plus X plus X plus 1. So I'm adding this side, this side, this side, and this side, all 4 sides, and then I'm going to set it equal to the perimeter that they gave me at the beginning of the problem. I'm going to solve for X. X will be the length of SP, and then I'll add 1 to it to get the length of ST. So I have 1, 2, 3, 4 X's here. And then I have 1, 2. I'm going to solve for X by subtracting 2. 4X equals 52. Divide by 4, and X equals 13. So the length of SP is 13. And then the length of ST will be 13 plus 1, and that will be 14. So ST equals 14 and SP equals 13. So those were the two questions that were requested from section 5.1. And request to also work out 3 questions from 5.2. So I'm going to work out number 16, number 20, and number 22. Okay, so for number 16, we're going to write a proof. And I'll have my statement column and my reason column. Again, I'm going to state all of my given first. And there's a lot of it here. So I'm going to state that ABCD is a parallelogram. I also can see that W, X, Y, Z are going to be midpoints of AO, BO, CO, and DO. And that reason is given. Now what I'm going to do is establish the lengths of each of these. Now we learned that if this is a midpoint, then I know that it's going to be half of the length of the whole thing. So I'm going to establish for my second step here my midpoint theorem. So I'm going to state that the length of OW is going to be half of OA. And the length of OX will be half of OB. The length of OY is going to be half of OC. And the length of OZ will be half of OD. And this reason is the midpoint theorem. Remember, whenever we saw that 1/2 in the statement, that gave us the clue that it was the theorem and not the definition. My third statement that I'm going to make is to show the congruent parts that it makes. So I'm going to state that AO is congruent to CO and that DO is congruent to OB. And this is the diagonals in a parallelogram are bisected. Next, I'm going to use that information and I'm going to substitute. So I'm going to say that OW is equal to 1/2 of CO. Because if you remember up here, OA and the OW, so now I can replace OA with CO. And then I'm also going to replace OX with 1/2 of OD. And this is substitution. I'm going to do it one more substitution. And I'm going to state that OW equals OY and OX equals OZ. And again, substitution. You can repeat the same reason over again. And then lastly, I could state that W, X, Y, Z is a parallelogram, and my reason is if diagonals bisect each other, then I have a parallelogram. So if diagonals bisect each other, then we have a parallelogram. So that was that proof. That one was a little bit different than what you're used to. So let me go ahead and show you how to solve for X and Y that would make these two quadrilaterals a parallelogram. Now, for number 20, you're actually going to have to factor this question. So again, we're reviewing our algebra skills within this question. You will not have to factor anything on tomorrow's test. So remember, in order for this to be a parallelogram, what we would have to show is these diagonals were bisected. So what we would do is set y squared equal to y plus 30. I now need to get this into a form where I can solve for y. So I'm going to move the y over. Y squared minus y equals 30. Subtract 30. Y squared minus y minus 30 equals 0. Now in order to solve for y, I have to factor this trinomial. So I'm looking for the factors of negative 30, that when I add them, and in this case I'll be subtracting them, to get a negative 1. Those factors are going to be y minus 6 and y plus 5. I'm going to set each of the factors equal to 0. So y minus 6 equals 0 and y plus 5 equals 0. Add 6, y equals 6, subtract 5, y equals negative 5. So now what I have to do is solve for x. So these are my two values that y could have in order for this to be a parallelogram. Now let me do the same thing for x. Remember, these diagonals have been bisected. So over here I'm going to do 3x minus 40 equals x. I'm going to move my x's together. Let me move the 3x over here. Negative 40 equals negative 2x. Divide by negative 2. X equals 20. So the values of x and y that would make this a parallelogram would be y equals 6 and y equals negative 5 and x equals 20. Now let me go ahead and do number 22. What I would need to try to figure out here is realize that we have some alternate interior angles going. So if these lines are parallel by definition of a parallelogram, then I would have a transversal here, and that would make this angle congruent to this one, and then this one congruent here. So let me go ahead and write my equations. Now notice when I go to set these up, I'm going to have both an x and a y. This is where I'm going to solve a system of equations. So if I do the blue one, 9y equals 4x plus 1. And then my other equation, let me go ahead and do this one in red so it shows up a little bit better. 3x equals 7y minus 2. Now whenever I have two different variables in my equations, what I'm going to do is work with both of these, and I'm going to solve using elimination. Now I'm going to go ahead and get it into standard form. So what I'm going to do is move the 4x to the other side, and let me do this one in blue. So negative 4x plus 9y equals 1. Over here I'm going to move the y over. 3x minus 7y equals negative 2. So now I'm going to take my two equations and I'm going to put them on top of each other, just so I have a better look at this. Now, if you recall from Algebra 1, to solve a system of equations, we need to eliminate one of the variables. And the way that I'm going to do that is I'm going to use the elimination method, and I am going to try to eliminate my x's. So what I'm going to do is I'm going to multiply this equation by 3 and this equation by 4. Now when I multiply the equation, I must multiply all three numbers. So this equation will now become negative 12x plus 27y equals 3. And then this one will become 12x minus 28y equals negative 8. I now can add my two equations together, which will eliminate the x. 27 minus 28 is negative 1y. 3 minus 8 is negative 5. And then now I can divide by a negative 1 because I don't want a negative y. So my value of y is 5. And now to get my value for x, I can plug it back into one of my equations. It doesn't matter which. I'm going to go ahead and use this one. So I'm going to take what y equals, put it here. 3x equals 7 times 5 minus 2. 3x equals 35 minus 2. 3x equals 33. Divide by 3. And x equals 11. So the two values, the value of x is 11, the value of y is 5. you will have to solve a system of equation on the test tomorrow. So those are the questions that you wanted to see worked out. I'll go ahead and post this for you.